Calculate the coordinates of the x and y intercepts for the following quadratics. Give each intercept as an ordered pair. Let's start with A. We're given y is equal to 3x squared plus 2x minus 1. To find the y-intercept, we substitute 0 for each x and then evaluate for y. We get 3 times the square of 0 plus 2 times 0 minus 1, which evaluates to negative 1. So the y-intercept is the ordered pair 0, negative 1. To find the x-intercepts, we substitute 0 for y and then solve for x. We get the quadratic equation 0 is equal to 3x squared plus 2x minus 1. We'll attempt to solve this equation by factoring and then use the quadratic formula if we get stuck. We first of all think of two factors that multiply together to give us 3x squared. Let's try 3x and x. Next, we think of two factors that multiply together to give us negative 1. The only choices are negative 1 and positive 1. We then check to make sure that we get the correct middle term. If we multiply 3x by 1, we get 3x. If we multiply negative 1 by x, we get minus x. And 3x minus x is equal to 2x. So we factor the quadratic expression correctly. Now we can apply the zero factor principle. The only way that the product of two factors can be 0 is if one of those factors is 0. So either 0 is equal to 3x minus 1 or 0 is equal to x plus 1. Solving the first equation gives us x equals 1/3, and solving the second one gives us x is equal to negative 1. So the x-intercepts as ordered pairs are 1/3 0 and negative 1 0. We can use our calculator to visually check our results. First of all, we go to y equals to enter our function. We enter 3x squared plus 2x minus 1. We then create a good viewing window. I'm going to select zoom and then number 4 zoom decimal. We see that the graph is a parabola and we want to verify the intercepts. So for the y-intercept, we know that we need to let x be 0. So we'll go ahead and use trace, and the x value by default is 0, and we see that the corresponding y value is negative 1. So the y-intercept is 0, negative 1. We've determined that our x-intercepts are at 1/3 0 and negative 1. So let's go ahead and enter 1/3 for x. We see that when x is equal to 1/3, the y value is 0, and the cursor is blinking on one of the x-intercepts. Let's enter negative 1 for x. We also see that the point negative 1 0 is on the graph, so we found the intercepts correctly. For b, we have the quadratic function y is equal to 3 times the square of x minus 2 minus 1. We use the same strategy to find the intercepts. To find the y-intercept, we let x be 0 and then we evaluate. 0 minus 2 is negative 2. The square of negative 2 is 4. 4 times 3 is 12. And 12 minus 1 is 11. So the y-intercept is 0, 11. To find the x-intercepts, we let y be equal to 0 and then solve for x. First, we add 1 to both sides. That gives us 1 is equal to 3 times the square of x minus 2. Next, we divide both sides by 3. That gives us 1/3 is equal to the square of x minus 2. Next, we take the square root of both sides. Now here we have to remember that every positive number has two square roots, one positive and one negative. We get plus or minus the square root of 1/3 is equal to x minus 2. Finally, we add 2 to both sides of the equation, and we get x is equal to 2 plus or minus the square root of 1/3. To rationalize the denominator of our square root, we multiply 1/3 by 3 over 3. We get x is equal to 2 plus or minus the square root of 3 over 3. 1 times 3 is 3, and 3 is not a perfect square, so we just leave the numerator as the square root of 3. 3 times 3 is 9, and the square root of 9 is 3, so the denominator is just 3. Finally, we might get a common denominator so that we can combine these two terms together. We can write 2 as 6 over 3. So our end result is that x is equal to 6 plus or minus the square root of 3 over 3. Therefore, we have our two x-intercepts, 6 plus the square root of 3 over 3, 0, and 6 minus the square root of 3 over 3, 0. For part C, we have the quadratic function y is equal to the factor 5 minus 2x times the factor 3 plus 5x. So again, we use the same strategy. To find the y-intercept, we substitute 0 for x and then evaluate for y. We get the factor 5 minus 2 times 0 times the factor 3 plus 5 times 0. The first factor simplifies to 5 and the second factor simplifies to 3. 5 times 3 is 15. So the y-intercept is 0, 15. To find the x-intercepts, we substitute 0 for y and then solve for x. We get the equation 0 is equal to the factor 5 minus 2x times the factor 3 plus 5x. The right-hand side is already in factored form, so we can use the zero factor principle. Either the first factor must be 0 or the second factor must be 0. So we get 5 minus 2x is equal to 0, or 3 plus 5x is equal to 0. We solve each of these equations for x, and we get x is equal to 5 halves, or x is equal to negative 3 fifths. So the x-intercepts are negative 3 fifths 0 and 5 halves 0. For part D, we have the function f of x is equal to x squared minus 5. To find the y-intercept, we substitute 0 for x and evaluate f of 0. We get the square of 0 minus 5, which simplifies to negative 5. Therefore, the y-intercept is the point 0, negative 5. To find the x-intercepts, we substitute 0 for y. Now in our equation, we don't see y explicitly written down, but we understand that the symbol f of x denotes our variable y. So we're going to put 0 in place of f of x and then solve for x. We get 0 is equal to x squared minus 5. To solve for x, we first of all add 5 to both sides, and we get 5 is equal to x squared. Next, we take the square root of both sides, and again, we remember that every positive number has two square roots, one positive, the other negative, so we get x is equal to plus or minus the square root of 5. Therefore, the x-intercepts are negative radical 5, 0, and the square root of 5, 0. Finally, for part E, we have the function f of x is equal to x squared plus x plus 1. To find the y-intercept, we substitute 0 for x and evaluate f of 0. We get the square of 0 plus 1, which evaluates to 1. So the y-intercept is 0, 1. To find the x-intercepts, we substitute 0 for f of x and then solve for x. We get the quadratic equation 0 is equal to x squared plus x plus 1. To solve this equation by factoring, we would have to think of two factors of 1 that add up to the number 1. But there aren't any two integer factors of 1 that add up to 1, so we can't solve this problem by factoring. We'll need to use the quadratic formula. In this case, a is equal to 1, b is equal to 1, and c is equal to 1, so we substitute 1 for a, b, and c in the quadratic formula. We get the opposite of 1 plus or minus the square root of the square of 1 minus 4 times 1 times 1, all divided by 2 times 1. When we simplify this, we get negative 1 plus or minus the square root of negative 3, all divided by 2. Well, at this point, the square root of negative 3 is not a real number. Therefore, our solutions for x are going to be imaginary numbers, and they will not correspond with any x-intercepts. So this graph does not have any x-intercepts.